Quantum entanglement, the new era of science. Welcome, fellow space and science enthusiasts. Today, we're diving headfirst into one of the most bizarre, mind-boggling phenomena in the entire cosmos, quantum entanglement. This is the real deal, tested and proven by physicists, and it's weirder than anything you'd find in a galaxy far, far away. We're talking about particles linked in such a way that they can communicate with each other instantly, no matter how far apart they are. Imagine two particles, billions of light years apart, acting in perfect unison. Hi, this is Rumella from Awakening Sci-Fi Stories. Get ready to have your mind blown wide open as we unpack the top 10 most amazing facts about quantum entanglement. Alright, imagine two electrons just chilling out in the vast expanse of space. We're not talking about a little distance here, folks. I'm talking about light years apart. Now, according to quantum mechanics, these two electrons can be entangled. It's like they're connected by an invisible thread. A cosmic umbilical cord, if you will. Here's the kicker. If you measure the spin of one electron and find it spinning up, you instantly know the other electron is spinning down, even if it's billions of light years away. And when I say instantly, I mean instantly. No lag time, no signals traveling at the speed of light. It's as if they communicate instantaneously, defying the laws of physics as we know them. This mind-boggling phenomenon is what physicists call non-locality. It's the idea that two entangled particles can influence each other instantaneously, regardless of the distance separating them. It's like they're two parts of a single unified system, even when separated by the vastness of space. Now, I know what you're thinking. Neil, this sounds like pure science fiction. And you wouldn't be blamed for thinking that. It sounds absolutely bonkers, I agree. But here's the thing. It's been experimentally verified countless times. Scientists have entangled photons, electrons, even entire molecules, and observed this spooky action at a distance. The implications of this are huge, potentially rewriting our understanding of space, time, and the very fabric of reality itself. So buckle up, folks, because we're just getting started. Now, even the biggest brains in history had trouble wrapping their heads around quantum entanglement. In fact, it challenged the very foundation of physics as understood by none other than Albert Einstein himself. You see, Einstein, along with physicists Boris Podolsky and Nathan Rosen, proposed a thought experiment in 1935 that became known as the EPR paradox. They argued that if quantum mechanics was complete, then it should be possible to know both the position and momentum of a particle with perfect accuracy. However, Heisenberg's uncertainty principle, another cornerstone of quantum mechanics, states that it's impossible to know both of these properties simultaneously with perfect precision. So, Einstein and his colleagues devised a clever thought experiment involving two entangled particles. They argued that if you measure the position of one particle, you can instantly know the position of the other particle, even if it's light years away, due to their entanglement. Similarly, measuring the momentum of one particle would instantly reveal the momentum of the other. This, they claimed, violated the uncertainty principle because you'd be able to know both the position and momentum of the distant particle without directly measuring it. This seemed to suggest that quantum mechanics was incomplete, that there must be some hidden variables we weren't accounting for. The EPR paradox sparked a fierce debate among physicists that continues to this day. For decades, the EPR paradox remained a thorn in the side of quantum mechanics, a seemingly unresolvable mystery. Then, in 1964, physicist John Bell came along and shook things up with his groundbreaking theorem. Bell's theorem offered a way to experimentally test whether the spooky action at a distance predicted by quantum mechanics was real, or whether there were some hidden variables at play, as Einstein suspected. Bell's theorem essentially set up a statistical test. It stated that if measurements on entangled particles followed a certain pattern of correlations, then Einstein's idea of hidden variables would be correct. However, if the correlations violated this pattern, then quantum mechanics would be vindicated, and spooky action at a distance would be real. The beauty of Bell's theorem is that it took the argument from the realm of thought experiments to the realm of experimental verification. This paved the way for a series of groundbreaking experiments in the decades that followed. Now, let's talk about something straight out of science fiction: quantum teleportation. I know, it sounds like something out of Star Trek, but I assure you, this is real science, and it's happening right now in labs around the world. But before you get any ideas about teleporting yourself to a tropical island, let me clarify what we're talking about here. Quantum teleportation isn't about transporting matter, but about transferring quantum information, the state of a particle, from one location to another, instantly, using the power of entanglement. Think of it like this. Imagine you have a coin, and you want to send the information about whether it's heads or tails to someone far away. In quantum teleportation, you would entangle a pair of particles, sending one to the sender and the other to the receiver. The sender then performs a measurement on their entangled particle and the coin, sending the result of that measurement to the receiver through a classical channel, like a phone call or the internet. Well, the future is entangled. Hold on to your hats, folks, because we're about to enter the world of quantum computing, where entanglement isn't just a weird phenomenon, it's the very engine driving a technological revolution. You see, traditional computers, the ones we use every day, store information as bits, which can be either a 0 or a 1. Quantum computers, on the other hand, use qubits, which can be a 0, a 1, or both simultaneously. Thanks to the magic of superposition, another mind-bending concept from quantum mechanics. But here's where entanglement comes in. By entangling qubits, we can create powerful connections between them, allowing quantum computers to perform calculations at speeds unimaginable for classical computers. We're talking about cracking the complex codes used in cryptography, designing life-saving drugs, developing new materials, revolutionizing artificial intelligence, and so much more. Now, let's talk about Einstein's famous diss of quantum entanglement spooky action at a distance. Einstein, despite being one of the founding fathers of quantum mechanics, never fully embraced its weirder aspects, especially this whole entanglement business. He just couldn't stomach the idea of information traveling faster than light, violating his beloved theory of special relativity. He called it spooky because it seemed like magic, like two particles were communicating telepathically, violating the fundamental laws of physics as he understood them. But here's the thing. Despite Einstein's reservations, experiment after experiment has confirmed the reality of entanglement. What is quantum cryptography? Imagine a world where communication is completely secure, where secrets can be shared without the fear of eavesdropping. That's the promise of quantum cryptography, a revolutionary technology that leverages the power of entanglement to create unbreakable codes. Here's how it works. Imagine two parties, Alice and Bob, want to share a secret message. Using quantum cryptography, they can create a secure key by sending entangled photons between them. Any attempt to intercept these photons would disturb their entangled state, alerting Alice and Bob to the presence of an eavesdropper. Quantum entanglement isn't just a theoretical curiosity, a mind-bending concept confined to the pages of physics textbooks. Over the past few decades, scientists have conducted increasingly sophisticated experiments that have confirmed the reality of entanglement beyond any doubt. One of the most famous experiments was conducted by Albert Einstein and his team in the early 1980s. They used entangled photons to definitively prove the violation of Bell's inequalities, providing strong evidence in favor of quantum mechanics and spooky action at a distance. Since then, scientists have entangled not just photons, but electrons, atoms, and even larger molecules, pushing the boundaries of what's possible. Now, let's dive into one of the most perplexing mysteries in quantum mechanics, the measurement problem. You see, in the quantum world, particles exist in a superposition of states, meaning they can be in multiple states simultaneously. It's like a coin spinning in the air, both heads and tails at the same time. However, the moment we try to measure the state of a quantum particle, the superposition collapses, and the particle chooses one state or the other. This raises profound questions about the nature of reality and the role of the observer in quantum mechanics. Imagine a future where the internet is not just a network of computers, but a network of entangled minds, where information is shared instantly and securely across vast distances. This is the dream of the quantum internet, a revolutionary technology that promises to transform communication, computing, and our understanding of the universe. The quantum internet would rely on entangled particles to transmit information, creating a network that is inherently secure and exponentially faster than anything we have today. It would connect quantum computers, sensors, and other devices, creating a global quantum network with unimaginable capabilities. So there you have it, folks, 10 mind-blowing facts about quantum entanglement that I hope have left you just as awestruck as I am. From spooky action at a distance to the promise of quantum computers and the quest to understand the very fabric of reality, quantum entanglement is a journey into the heart of the universe's greatest mysteries. And don't forget to like, share, and subscribe for more mind-expanding explorations into the cosmos.